Hello, Mr. Stack here. I miss you in class today, but we're going to do some notes together here on solving systems in word problems. And I'm not sure your relationship with word problems in the past. Mine hasn't always been the greatest, but I've kind of learned to love these. One, because there's no shortcuts at the end of the day. It really does make you think, which is actually interesting instead of just going through blindly the motions. And second, these are actually really important because they're going to be appearing a lot on the ACT. So it's good practice there. And then lastly, it's just like, it's very engaging because it kind of like puts together all aspects of your brain. There's reading, there's comprehending, and then there's math as well. So let's dive into this. We are talking about solving systems, word problems. In systems, if you remember, means that you have two or more equations, which actually makes our word problems here a little bit easier than typical word problems because we know there's going to be two equations with two variables. So let me show you what I mean. For the first problem, please make sure to read each problem. And let's start with number 1. First, find the value of two numbers if their sum is 12 and their difference is 4. So like I said before, right? We're not just going to be randomly dividing and multiplying numbers. Our goal here is to set up our two variables, and then we're also going to have two equations. We're then going to solve those systems either by substitution or elimination. So let's dive into this first one. Let's define x, our number that we don't know in math, as the first number. And process of elimination, we're probably going to call y that second number. From here, we're going to set up our two equations. The first one refers to their sum, and the second one refers to their difference. Sum means addition, and difference means subtraction. So for my first equation, the sum, x, the first number, and y, the second number, is 12. The second equation is going to be x minus y equals 4. And look at this. We have our two equations now. We have interpreted them, and now it's time to solve this system. And we have to ask ourselves, do we want to do substitution or elimination? Take 10 seconds to think to yourself here. Which would be the most efficient method, and why? It's not going to be substitution, and the reason why is because we don't have something like y equals or x equals. A variable is not alone, but what I do notice here is that the x variables and the y variables are stacked on top of each other. See, you can't escape me even when I'm absent. So what we're going to do is combine these equations with addition, and you'll see that these equal and opposite variables, these y's, actually cancel to 0. When I add the x's, they don't cancel even though they're the same. They combine to 2. And then 12 and 4 make 16. Yes? Yeah. Okay. And then this is 2 times x, and I divide by 2 to get x alone. And I get that x is equal to 8. Remember that I am not finished with this, and I have to get y as well. I could plug into the top equation, and I could plug into the bottom equation. I'm going to go the top just because there's addition there. So x plus y equals 12. X comes out, and 8 comes in. From there, we're going to solve for y in one step by subtracting 8 to both sides to get y alone. And I get that y equals 4. Last step, write your answers in ordered pair. And before you leave a problem, you should ask yourself, like, does it make sense, right? Remember, we're solving a word problem here. Are the sum of these two numbers 12? Is the difference of 8 and 4 4? Yes, we can move on. Good morning. Let's take a look at number 2. I'm recording a video.
I love that.
Julio works 8 hours and Maria works 10 hours. Their combined pay was $80. When Julio worked 9 hours and Maria worked 5 hours, their combined pay was $65. Find the hourly rate of pay for each person. So let's break this down. First, I suggest one strategy is to look at the question, and that will tell you your variables and what to solve for. So I need to find the hourly rate of pay for each person. So that probably means I should probably define the hourly rate as my variables. Instead of using X and Y, I'm going to use J and M. The reason why is it just helps you remember what J actually stands for and what M actually stands for. In this case, that is the hourly rate. You can just write rate of Julio. And M is going to be the rate of Maria. Now, our goal is to set up two equations, right? So let's break this down again. We kind of dealt with the question, so let's reread this carefully. Julio worked 8 hours and Maria worked 10 hours. Their combined pay was $80. Do you see how that sentence kind of clumps information together? That's because that's your first equation. Taking a look at the second sentence, oh my gosh, when Julio worked 9 hours and Maria worked 5 hours, their combined pay was $65. That second sentence refers to the second equation. It's kind of clustered together. So if I were to turn that into an equation now, Julio worked 8 hours. 8 hours corresponds to Julio. And Maria worked 10 hours. Again, combined means add. Their combined pay was $80. Can you think of what the second equation is going to be? That is going to be 9J and 5M is equal to 65. Clearly, like we discussed before, elimination is going to be our best option here. So who do we want to eliminate is now the question here, because the numbers are not the same, sadly, for J and for M. So nothing quite cancels when I add right away. So I have to do some multiplying. So which is going to be easier, M or J? If you thought M, that is absolutely correct because 5 nicely multiplies to 10. And so I'm going to actually make a mistake here. Tell me what it is. I am going to multiply this entire second equation by 2 in order to get the M's to cancel. So let's just kind of work that through. Don't write this down yet. What's my mistake? Does anything cancel? No, and the reason was we forgot a negative. They need to be equal and opposite. So when I change it to a negative, that changes that to a negative. That changes the 10 to a negative. And that changes my 130 to a negative. Remember, when you distribute, it goes to all three numbers, 1, 2, and 3. From there, things do cancel. That was the whole point of multiplying. And let's add our equations together. These cancel. That was the whole point. This combines to negative 10j. And this combines to negative 50. Thank goodness that's a negative, because now when I divide by a negative 10, my answer actually does make sense. It's a positive number. Imagine if they were losing money per hour. That'd be kind of sad. So what does this 5 represent? You need to tell the reader this, especially as you guys are going into data modeling next year. You need to be very specific in how you define your answer. You need to tell me what it is. What does 5 represent? Well, J is 5, and J is the rate of Julio. So Julio makes $5 per hour. Is that a good hourly rate? Probably not, but I guess he deals with it. From there, we are not done, sadly. That's half of our answer now. Let's go get M. I'm going to do the equation that probably has the smaller numbers, so I'm going to go to the bottom one, just because it's less likely to make a mistake. And then I plug in $5 per hour for J, right there. J comes out, 5 comes in. And now it's time to solve for M. So let's start by simplifying the left-hand side to 45. Plus 5m is equal to 65. Subtract 45 to both sides. We wouldn't divide by 5 yet because that term is not alone. That is going to be our second step though. So I believe this is 20. And then when I divide by 5, I get that m is equal to 4. But for what? For Maria's? For hours that she's working? No, this is going to be $4 per hour for Maria. And there is your solution. Let's do just a couple more. So I think this is number 3 for you all. So let's kind of do this one together as well. So in the basketball game, Joey made 19 baskets, some 2-point shots and some 3-point shots for a total of 40 points. How many 3-point baskets did he make? So again, my first thought is to look at that question. I kind of read that fast. I didn't really process what I read. So I'm probably going to have to slowly reread the question again after I take a look at that question. So how many 3-point baskets? Well, there's 2 kind of baskets, right? There's 2-point and there's 3-point. So that's probably my X and Y. Since 2 and 3 points sadly both begin with T, I'm going to use X and Y here. So X might stand for the 2-point shots. And when I'm talking about 2-point shots, I'm talking about the number of them. And Y might be the number of 3-point shots. Since I read the original question kind of fast, it's time to reread that and look for my 2 equations. So in a basketball game, Joey made 19 baskets. Okay. I processed that. Some 2-point shots and some 3-point shots for a total of 40 points. Okay. I noticed for the second equation that this information is kind of clumped together. One other tip that I have is focus on the units. 2-point, 3-point, 40 points. So one equation is likely going to deal with my points. Specifically, well, 2 points is X, 3 points is Y, and that is going to be equal to a total of 40 points. Okay, so the only number I haven't used is 19. Meaning that like it is 19, right? That's the total amount of baskets. So it's probably equal to 19. But I don't see any other numbers here. If I were to classify this second equation and kind of give it a name, I would say like the number of baskets, right? Well, baskets can be broken down into two things, right? 2-point shots and 3-point shots. That's the total amount of shots. So when they don't give you any other information like that, normally that means it's going to be X plus Y, right? The number of 2-point shots plus the number of 3-point shots equals the total amount of shots. It makes sense. Did you see what I just did there? And how I kind of reinterpreted my equation to see if it made sense? That is another strategy that I suggest you use. From there, we're going to do, oh my gosh, look at this, another elimination one. You could do substitution and like solve for X and Y in the bottom equation, but I think elimination is good just to get comfortable with. So let's do it. Does anything cancel right away? Sadly, no. So I'm going to have to multiply. And looking at my X's, looking at my Y's, I know I'm going to have to multiply this equation to take the smaller numbers to the bigger numbers. And likely I'm going to go with 2 just because I don't want to multiply by 3. That's bigger. Just like before, remember, it's not just 2. It's negative 2. So that it cancels. I distribute. I'm going to rewrite the top equation just so things don't get messy. And here comes the bottom equation. Pay attention to my colors. 19 times 2, 20 times 2 is 40, minus 2 is 38. And then careful with that negative sign. If you do get a decimal answer, ask yourself, 1, does it make sense? Is it like money? Then it's okay to get a decimal. But are you going to have like 2.5 3-point shots? Like, no, that just doesn't make sense. If you made an error, it's probably with your negative signs when you distribute. So the whole point of this was to cancel our 2x. It's like deja vu. 3y plus negative 2y is just 1y. And then 40 minus 38 is just 2. And then lastly, tell me what that means. 2 what? 2 3-point shots. We are almost done. Let's deal with this by putting it into the last equation. Again, because it's simpler. Mathematicians are a little bit lazy, right? You want to kind of minimize the amount of work you have to do, so you also minimize the amount of errors you make. We solve for x by subtracting 3 to both sides. And we get that x is equal to 16 2-point shots. So remember, when you're doing a systems word problem, there are 2 equations, 2 variables, and 2 answers. That's what makes these word problems a little bit more manageable than typical word problems. You're not just dividing. If I were to give you a recap on the strategies we used, 1 is rereading the question. Second, take a look at the last line to help you define what you're looking for in your variables. And then also pay attention to your units. Points, points, points. Money, money, money. They will all kind of go together. So that brings us an end for today. Thank you for taking quality notes. I want you to please head to student.desmos and submit your notes as a picture or a screenshot to Desmos for points today. Thank you so much. I missed you today, and I hope you have a good one. Good luck in your skill check. Bye.